Thanks everybody for turning up on a Saturday. I think Avinash did quick introductions, but I think it'll be useful for the panel members to just briefly talk about themselves. We can go in the reverse order. Rayees, do you want to go first?
Sure. Can you guys hear me okay? All right. My name is Rayees Pasha. I lead the product team at RisingWave Labs. So RisingWave Labs is for those who are not familiar with us, we're a stream processing database. What that means is basically we put Flink and Postgres in one solution. Not literally, but the functionality wise. So you can do stream processing on fast moving data, but since we have a built-in storage engine, it allows you to serve the data as well. So it's a combined solution. My background in data goes a long way back, a couple of decades. I started out as an engineer working on a relational database. I don't. Quick show of hands. Who among here know tandem computers or nonstop SQL? I guessed it right. I don't think anybody would know. So you knew, okay. So yeah. So it's an old system from the 70s, sort of actually ahead of its time. So not that probably dates me in terms of how old I am, but yeah, I was an engineer and then moved to product management. But I've been close to databases, big data systems. Looking forward to a lively discussion here.
Yeah, hello, I'm Ralf Debusmann. I'm just from Flunin, from Switzerland. So my background is, yeah, actually AI stuff, old school AI. So I was studying and doing my PhD in NLP like 20 years ago. But basically I switched over to like software development and stuff afterwards because there was no jobs in AI at the time, of course. So basically, I ended up finding Kafka and stream processing about 2014, and I'm working in this space since then in German companies mostly, or Swiss companies like SAP or Bosch, and now at Migros, which is a big retailer in Switzerland, but nobody knows it because it's not doing a lot of business outside Switzerland. Yeah, and of course, I also co-wrote this book with Hubert Dulay, and Matthias wrote the foreword, which is, yeah, you should get it alone for this. And yeah, and I'm interested in this book. Also wrote this book because I'm interested in this like kind of convergence and all this different difficult terrain around streaming and databases and where they converge and where not, and OLAP and OLTP and row-based versus column-based and Iceberg and all that stuff. It's got very complicated, but maybe we can clear up it a little bit here. Thanks.
Yeah, beautiful book. I can just recommend it. I read it cover to cover. So not just wrote a foreword without reading it first. So it's high quality. Yeah, I'm Matthias Sachs. I currently work as a software engineer at Confluent. Before Confluent, I was working on my PhD, focusing on stream processing. Worked on a couple of different systems like Apache Storm, Apache Flink, then Kafka. My main focus is Kafka Streams. But yeah, we also worked on KSQLDB for a couple of years, or I worked on KSQLDB for a couple of years. It's still around, obviously. So yeah, kind of stream processing history for a couple of years now.
So since you mentioned stream processing history, maybe that's a decent segue into this panel conversation. So from your academic days, as well as your work on Kafka, Storm, Kafka Streams, Flink as well, help us unpack a little bit of the last 10, 15 years of stream processing and what you've seen and where you see kind of the future of these systems evolving into.
Yeah, I mean, from an academic point of view, it started like early 2000s when big universities in the US started to do research on stream processing systems. Was a completely new concept. And we made a long way back then. Obviously, it's almost 25 years now. Those systems were really like just struggling with the most fundamental things. Nothing was distributed, nothing was data parallel. And they were also not like super successful commercially because they were just not useful yet. Let's put it that way. And then this big transition came with the big data era, with Hadoop and stuff like that. And then I think this kind of second generation of stream processing systems came along, where they basically tried to marry concepts from this big data Hadoop world and basically do high-scale stream processing. And then I would say the third wave is then later coming with SQL-based systems, because you always have this problem if you have something like an Hadoop or an Spark or whatever, right, and you need to write Java code, you limit the audience significantly. And SQL was obviously a major drive for the success of relational databases. So all of these different players started to do it with all kind of different flavors of SQL and different ideas. And I also don't think we are there yet. I mean, streaming SQL is not something that is standardized or something like that. So that's going to be interesting in the next 10 years how this evolves further. And in general, I think stream processing will go very deep also into the database space. Not sure if all databases will adopt it, but I think it will become a commodity to some extent. So if you look at systems like Materialize, for example, with incremental Materialize views maintenance, it's just such a next logical step. And you can actually hide the stream processing aspect of it from the user to a large extent. And I think that has a very bright future.
Sure. Yeah, I think my take is largely aligned with what Matthias mentioned. To me, the bigger trend is there was a bright line between batch processing and stream processing. That seems to be fading, as opposed to a binary choice between having to do batch versus streaming. It's more a spectrum. Some of the workloads that you could do with batch could be handled streaming because of the maturity in the platforms. And a big factor is the adoption of SQL. If you have a SQL, that becomes your common language, common ground. So what you could do on a batch side, you could replicate that on the streaming side with the streaming database. The underneath mechanics of how you actually do the processing from a full computation model to an incremental computation model, those details are hidden from the user for right reasons. But from an interface perspective, so it's really easy, right? So you can get started right away. I think that's a clear win. And more workloads can be, not all of them, but more and more will transition to a more, on the streaming side. And then no longer it's the niche that it's always been put up to be. So.
Yeah. Yeah. So maybe actually thought about what to say here less an hour ago. So I think we should also talk about the motivations for stream processing. I mean, why do we do this at all? Why don't we just dump every Kafka topic into a database and work from there? Which is actually what most people are doing, right? So especially in the data warehouse world, they just take data from Kafka, put it there, and then they run ultra expensive BigQuery or Snowflake queries and look at their bill and wonder. So the question, why do we do this? I mean, of course, in the stream processing world in the last 15 years, I think it was mostly about real-time use cases, right? I mean, you always hear fraud detection and all that stuff. But I think a second reason is also just to have incremental processing. So you want to actually use and exploit that you can do incremental processing with stream processing. You don't have to go through all the data all the time when you do transformations. You have to just take the latest data point, the latest delta, and work with this, right? And that could actually bring down the cost for transforming data quite a lot. And now the next question is, why isn't stream processing used for that? Why, in the real world, like excluding the real-time use cases now, why isn't stream processing being used by the guys who, for example, work with BigQuery or Snowflake? And for me, the problem is the SQL semantics, right? Because all the stream, that's one of the biggest challenges. How do you how can you have an engine that has, I mean, SQL is, I mean, for example, Flink SQL, for example, or KSQL, they have SQL to some extent, but the semantics of the SQL, they're not like in a database. You want to have SQL in stream processing that behaves like in a database. And that challenge for me is not yet completely solved. So there's some new approaches. RisingWave, for example, or Materialize, they have engines which are more database-like. There is also a new engine called DBSP from the guys of a new startup called Feldera. They might have found an even more database-like solution for SQL semantics, but this is one of the questions for me that triggers me most.
Yeah. I think this distinction between incremental processing is very important because stream processing as a term is very broad. And there's many different flavors of stream processing. But especially for incremental processing in databases, I think it actually is one of these, I wouldn't call it a niche, but one of these special use cases where you actually don't need to change the semantics significantly. I think that is actually why it can be successful by a bet on that one. If you, for example, look in KSQLDB, we added this create stream statement. So we added a stream as a first-class citizen. And obviously that puts a lot of like mental effort on people who are new to this space because they're used to tables. And that's kind of, now I have this stream saying, what is it? How does it work? How does the semantics work? And I agree with Ralph, we haven't figured it out. It was actually quite interesting. A couple of years back, some people came together and said, well, could we start to standardize streaming SQL and extend the existing SQL standard? And a couple of companies got involved, including Confluent, so we participated in that. And after like 2 or 3 years, we had to basically agree that we cannot standardize anything at this point because all the vendors have just vastly different approaches and the overlap is maybe like 5%, but you need to agree on like 60, 70, 80% that you can actually extend the standard. So, so that is still interesting. To the comment about unifying streaming and batch processing, I think this is actually marketing, not technical, because semantically both things are different. So I actually think if you really do this unification, it's actually a replacement because semantics are different. So streaming just takes over and batch goes away. I don't think there's anything unified because semantically there's a mismatch.
I disagree a little bit, but that's because, you know, I mean, you are true that it is a single engine cannot do both things, right? So in RisingWave, our approach has been that we have the streaming engine and the batch engine put together. If it's an ad hoc query, it has to be a batch engine because you have to go fetch the data, prepare a query, execute. So it's just, I think from a solution perspective, user has one tool to use, but under the hood, obviously the flow is a little different. So I admit that, but I don't know if there is this, you know, it's just the semantics and the plumbing is so different for streaming that you could ever answer an ad hoc question. It just doesn't work that way. Can I add something more? Okay. So on the cost part, right, you're saying that was a good point because a lot of people are focused on functional aspects, like what can I do this, can I do that, right? But the fear as well of the unknown is always cost. Like, oh, I inherit a new system, what that would mean for me, right? I think with streaming, one thing that people should learn. I mean, this is something that we experience with our own customers, right? Some of the customers don't really need ultra low latency, millisecond latency. All they're doing is more predictable delivery of data. What they would take to run overnight jobs, which could run over and then makes the analyst mad. Like, oh, I came into office, I was expecting a report, I don't have it because there was a spurt of data and the cluster couldn't handle it, right? What streaming offers is to basically convert those workloads to run throughout the day in a continuous fashion so that you amortize the cost throughout the day as opposed to running a huge workload. So it's not even traditional stream processing. It is just your standard workload, data preparation workload. You have de-risked it by making it more predictable. The side effect is even though you may not need it throughout the day fresh data, you get that as a bonus for free. And your cost is you still are running a small cluster, much smaller than what you would need for a full computation. So even if the cost is a wash, at worst case, you still get fresh data and you are predictable. Your analyst will be happy that, hey, my chances that it may not arrive have significantly gone down. So there's a business value for people who are still skeptic about whether I need, stream processing.
Matthias, you touched upon the different generations of stream processing as it has evolved. But just fast forwarding to where we are right now, right? With the Flink, Kafka Streams project, as well as the emerging trend of streaming databases. Could you offer us a sort of comparative view of this spectrum and where it stands on the programming model, as well as sort of consistency, completeness, correctness guarantees? What varies across the spectrum, and how does one go about choosing what fits their use case best?
Yes, that is a huge question. Yeah. I mean, in the market, what we see is a lot of different solutions. So there is not really a clear winner yet. That might also depend on the different use cases. What is the better fit for you? So to advertise a little bit, obviously I work on Kafka Streams. Very, very successful. But the focus of Kafka Streams is really event-driven microservices. This is where it shines, where it's great, and where it's a huge adoption. If you want to build like a streaming ETL pipeline, I mean, you could do it with Kafka Streams, but I would not necessarily recommend it. I mean, because it's not built for that, right? Similar thing with Flink. Flink is really optimized for super high throughput. So if you have a super high throughput use case, Kafka Streams at some point might become too expensive, and then Flink is a better solution, right? But in this world, you're still mostly in the Java world, right? In the programmer world. And then of course the SQL world, gives you different things. So with regard to consistency and stuff like that, or fault tolerance, I mean, all the systems basically nowadays have exactly one's processing semantics, so that's good. There's still a couple of things. So there was one interesting blog post at some point. I think that was from Materialize people about so-called internal consistency, because many of these stream processors are inherently async internally. And while data flows, the actual states that is tracked can actually diverge a little bit. And only when you stop the data stream, then it all converges to the same solution. But as long as the stream is running, then there could actually be fluctuations. And that can be a big problem. So the example was they had built this query, and semantically that the result of this query in the end was a multi-step pipeline should always be 0. But then those processes were running, and the result was just like going up between like 50 and minus 50 or whatever, and was just oscillating because it was not internal consistent. And I guess it again depends on the use case. So when those systems were built, that was just not important. But now when we enter this era of SQL, now it becomes very important, because in a SQL system, you would not accept that. While if you write a data flow program with Flink or with Kafka Streams, it's kind of, yes, that's fine. I know exactly how it works, right? So I think that is the main thing that we need to figure out. Not sure how good Rayees is on this front with internal consistency.
We don't claim like full asset guarantees of a OLTP database. There is no for transaction management where you can roll back and all that. But we do provide semantics of guarantees, consistency in the context of stream processing, like exactly once, at least once. You could tune those to ensure within the stream those are enforced. But I wouldn't run a payroll or something on RisingWave, because that's just not the purpose of this tool, right? One thing I also want to mention is consistency from stream processing systems that process the data for operational use cases versus analytics use cases. There is a difference, like especially with the adoption of Iceberg and all these systems, data formats, where if you write the data, how do you ensure that the consistency is maintained as the writes happen, right? So that's a core challenge we are solving. Like our Iceberg work actually takes it from that lens, not just for upstream, but also the end-to-end pipeline, that when you deliver, we have addressed any late arrivals in data, out of order processing, all that is handled so that the writes are consistent. Because when you run analytics workloads on that data, it has to be truth. It cannot be, because it's not transactional, but still it has to be accurate.
Yeah, I mean, the consistency bit seems to maybe have been figured out, I'm not sure, by the Feldera guys. So maybe have a look at that page, DBSP, there's also open source stuff, so let's make some marketing for them. They also have a pure Python implementation of that. So they claim to have built a consistent streaming engine, but yeah, stream processing engine. On another note, maybe to hark back to Pavan's question about the landscape of stream processing solutions, I think what's interesting is that this distinction between server-based solutions like Flink or Spark. I mean, we did mention Spark streaming, that's also there, and they have invested a lot into this now recently. And there's of course the library-based solutions like Kafka Streams, there's lots of new libraries coming out now, especially for Python, like Bytewax or Quix or Pathway. So there's more and more stuff coming. There's also RioDB, a very new one. So lots of stuff is coming now. And yeah, so I think this distinction is also interesting. So whenever you want to write something with code and you want to integrate stream processing into your code, then something like Kafka Streams is, I guess, still a very good solution. If you don't need massive scale, then you have to go to Flink in the end or Spark. On the other hand, yeah, I think, yeah, I'm not sure about Confluent's strategy. That would be another discussion here. So they have really gone to Flink as their main product, and maybe Olina can also add something later. I don't know, but it's interesting because that's a clearly server-based solution, which, like Matthias said, is Flink has basically been built for really high throughput use cases where it shines. But I'm not sure whether the strategy to really fully go into this direction is the right one, because there's so many use cases where you don't have so much throughput, where you don't even need real time. And for that, maybe the library-based solutions might also suffice. Not sure.
Yeah, it depends a little bit. I mean, in the end, as Confluent, we want to run a managed service, right? Because that is how we can make a business. That is the biggest problem for Kafka Streams at Confluent. We don't sell it, so there's no direct revenue attached. And so Flink is obviously much better here. For the high throughput thing, I think the solution here, that's also interesting for managed service. If you have a high performance system, you can just multi-tenant very aggressively. And then you can amortize the cost, and then you can, also for like low throughput workloads, can actually be very, cost efficient. We are not there yet. We're still ironing out a couple of kinks in our service, but that is basically the goal, and I think it makes a lot of sense. And it's also a lesson we have kind of learned from KSQLDB. I mean, KSQLDB internally uses Kafka Streams as the runtime engine. And at some point, we were at a situation where it's kind of, okay, we want to make basically the next iteration for KSQLDB. But because we use Kafka Streams internally, this is missing, that is missing. We need to re-implement a lot of things. And then we looked at Flink, and it was kind of, well, Flink has already like check marks for 80% of those things we would need to rebuild. And then we basically said, okay, let's make the pivot to save engineering costs. That was basically the main reason.
Sorry, I don't want to be a moderator, but I'll ask a question anyway. What's the future for KSQLDB then? Is there active development happening, or what's the Confluent's position on that?
Yeah, I mean, we have KSQLDB. You can still buy it. It's there. We do not invest a ton because obviously we move our focus on Flink at the moment. But I mean, something like KSQLDB, I mean, we have hundreds of customers using it. You do not just like switch it off overnight. So I'm pretty sure it will be around for another 5 to 10 years. So things move very slow, and then we have to see. The point is also we have customers where we now say, well, we have this new Flink thing. Do you want to migrate? And they basically say, well, is it significantly better or cheaper? And we're kind of, no, it's just a new shiny thing. And then they say, well, then I don't do anything. So, I mean, KSQLDB is not a failure or something like that. It was just like too expensive to basically go into the next generation. So yeah, it's still there. Enjoy it.
One of the other to segue into is what Ralph was mentioning as the big convergence around open table formats. So in any order, talk to us about what open table formats and stream processing in the lakehouse potentially holds. Is that viable? The sort of different table formats that are available. You have Hoodie, you have Iceberg, Paimon, and most incidentally controlled by Databricks now, but that's a side factor you might want to comment on. But do you see viability of stream processing workloads necessarily without the Kafka appendage, right? How do you look at it? Maybe Ralph, you can go first.
Maybe I give it to me. Oh, to you.
Yeah. The reason I'm grabbing is because I just gave a talk on that topic. So on stream, I called it streaming data lake houses, although it's a made up category. So don't look it up on the Google. But the notion is streaming first approach. How can you use your streaming infrastructure to ingest, process the data and prepare it for downstream consumption, right? So, our journey has been that our core competency is stream processing. So we didn't want to be distracted by these data lake houses and all the mega vendors who are following that. But we did want to provide some integration, basic integration in terms of source and sink, so that people can ingest the data from primarily Iceberg. That's the only thing we focused on because market was converging towards that. And sync support. What we noticed is that people were happy, but they were also worried that who takes care of these tables, the lifecycle management of those tables, compaction, and all that was a burden on the users. So the ones who are sophisticated had a solution. For the others, it's a problem. So then you are inheriting a new problem because you're using a fundamentally different architecture to do one part of it, while the rest of it is you're relying on another vendor. So latest thing that we have worked on in the last few months has been providing managed Iceberg service that is conducive to high velocity data. And it's been tuned to basically work as if you're like a streaming data lakehouse, for lack of a better word. So that's what we've been working on. Our first work that we did was analogous to what Confluent did with Tableflow, right? That was what we released about 6 months to a year back. But this basically means we can become your managed service, so to speak, if you choose to do so, right? Like from a streaming first approach.
Yeah, so I think it's also interesting that there's or where to put the data into Iceberg at that point. So for Tableflow, you still have Kafka. So you have Kafka, and then you have kind of a internal connector to Iceberg. There's also other ways. There's I think Red Panda announced it, but they didn't really do it yet. Finally, there's Stream, for example. We talked about this morning, which I think it does. I mean, you can maybe fill in here. It actually uses Iceberg under the covers for actually storing the segments, right, of the Kafka-like data. So it could be that you have like a normal Kafka and then Iceberg on a data lake separately and connectors between it. It could also happen that the storage of the broker really goes to Iceberg directly, right? So that these are things which are moving now. It's quite interesting, I think, and yeah, let's see where it's going.
Yeah, I mean, data warehouses are there, data lakes are there, not going away. I think those things are actually net new market with streaming. I don't think we're replacing data warehouses, and that should never be the goal. But yeah, streaming ingest, obviously, we talked about this before, right? It will be a big thing because in the end, you don't want to wait. I think it can also be actually more cost effective if you do streaming ingest instead of batch processing. And so, yeah, I mean, as you said, the industry seems to settle down on Iceberg as the format. That is why also Confluent is investing in it with Tableflow. But I think if you make this transformation, and there's nothing negative about it, you basically leave the streaming world and you go into the batch world because you actually land the data. Dataflow or Iceberg is basically a kind of a terminal format, right? You think it's there and then it stays there. And of course, you could then later on say you use some change data capture to streamify it again, but then you really bridge between the worlds, right? What we also do with Debusmann at the moment is kind of, well, you have a database and you streamify it to get the stream out. And as I said, I don't think the one will replace the other forever because if the main difference is really who is using the data and how it's used. And if we are humans, right? If you get an update to your report every 5 seconds, what do you do with it? For us humans, it's totally useless. And this merge of streaming is really, and now I copy from Jay, our CEO. It's kind of really this idea, or this trend, not an idea, it's happening, that more and more software is talking to each other. And if software is talking to each other, then obviously you can go as fast as you want, because we humans are just too slow to process it. And so for us, it's not necessarily like important. Obviously, if you have like an app, like an Uber or whatever, right, then you have the streaming interactions that's operational. But for those analytical workloads or whatever, or a data analyst is sitting somewhere and exploring data and stuff like that, so it's always human interaction. So it's always slow. And so basically this request response model is just like totally fine, because that is how we humans operate.
Do you see as the relevance for stream processing on the AI and ML inferencing side? A lot of what gets marketed today is, calling an inference REST call, directly out of a stream processing system. Is that fundamentally useful? What do you see it evolving to?
Yeah, I think there is something to it for sure. I mean, AI is obviously a very, very new trend, and we have to see how this develops. And I think there's two aspects to it that is relevant to stream processing. So one is what you just mentioned, is this kind of, I have an event coming in, and I want to use some AI agent or whatever, right? We had just heard a talk earlier from Molena about that, to react to this event. I think the other aspect, and that's also very important, is to enrich those agents with the latest data. So let's say you are an airline and you have some bot, and a customer comes in and says, give me my flight status. So if you have a generic model, it doesn't have any customer data. It cannot answer this question because you need to enrich it. And obviously, if I say, I rebook my flight, and 5 minutes later I ask the model, I expect the model to know that I already rebooked my flight. And I say, can you confirm that the flight was rebooked, or I changed my meal selection or something like that? And so here streaming is very important, because those models are generic, right? The model can tell you exactly how long a flight takes or whatever based on historic data, but you also, for good user experience, need to enrich it with live data. And this is the second component where I think streaming is very important.
So I think anecdotally speaking, you could come up with some use cases where, because the data is the powers AI and Gen AI, whatever. But for me, what we have seen from the customers or the users of our product, based on that experience, what I can say is we have a couple of customers who are using, basically, they had batch pipelines with Spark. They were training the data, they were fine-tuning their features, all that. But they had some special use cases that required intraday tuning, right? So that's where we have come in, be able to help. And in a couple of cases, feature store, basically because of the fast retrieval they've used us. So those are the limited use cases we have seen so far. And that's why it's hard to call ourselves anything, AI related, because we're not AI system, we are a data system, right? But possibilities are there. Like I read white papers where they say there's a future where the sort of grid microservice architecture will come between the agents where they communicate, and there's fair amount of data flowing within this agentic system that has to talk. Maybe that will be the next big step for stream processing, but yeah, at this point, it's just a conjecture, in my opinion.
Yeah, for me, like Matthias said, at the moment, the fresh data ingestion or into vector databases for RAG or for agents is kind of the most important part. Might not be such a big thing, but imagine, for example, that's a use case coming more from my world. As I'm working at a retailer, we have a chatbot which gives you the latest prices about a product. So you can ask, I'm looking for some product, and so we tell the customer, okay, the product, we have these products, these prices, and they are available at these locations. And for that, of course, especially for the prices and for the stock update, you need to have constant flow of data coming in. So that's definitely a use case, which is kind of at least intertwined with AI. But I don't see yet the real like killer application, or let's say like this, how stream processing can be a killer application which you need for doing AI. But agentic AI could be a different thing. I mean, I'm scared of it, to be honest, but yeah, put that away. But I think if you imagine that, and that's where the trend goes this year, where you basically replace orchestrated microservices that we had so far from the last 15 years. You replace these microservices with autonomous agents. I mean, a bit like Olena talked about before. Then, of course, if you have these agents or microservice or agentic microservices or whatever you would call them, then they have to communicate, and especially also because LLMs, while they are still pretty slow, you have a lot of latency, then you need to have a way to asynchronously communicate between these agents, right? These agents have to talk to each other asynchronously because otherwise it just takes too long. Imagine you have like 4 or 5 API calls and you wait for all of them before you can answer. Doesn't make sense. So that this could be one application for streaming, maybe stream processing as well, but not sure yet.
So I think we could do one more question before we just open up to the audience. But this is getting brought up somewhat frequently. Matthias, you touched upon incremental view maintenance, as did you, Ralph. So what do you see as the relevance of the sort of real-time OLAP layer? Our friend Fasi gave a talk on Pinot. So the triad of Pinot, Druid, ClickHouse, Doris. How do you see that and its overlap relative to incremental view maintenance systems, streaming databases for sort of serving layers, user-facing analytics? Do you see a convergence of these two things, or are they completely distinct in semantics?
Yeah, I think they're complementary. I mean, if you look at incremental view maintenance, it's basically on the right path, right? You have input data changing, and you're right. And obviously Pinot also ingests data, so that's basically the overlap here, but it's similar. But then the huge strength of Pinot is to say, well, now on the read path is the strength, because we allow very low latency with very high concurrent users, and that is basically unique for Pinot. No other system can do that. And again, it depends on the application, right? If you go back to like an Uber app or something like that, we have potentially millions of users. Then Pinot is the perfect system, right? Because you have this very high concurrent workload with so many users, and that is what you need. And then if you need both in the same system, right? Incremental, consistent maintenance and this user-facing things, that's TBD. I guess if there's a use case, then yes. Otherwise, it's kind of two different things. One is for the write path, one is for the read path, and they can be complementary. I don't think there's necessarily dependency, but there could be use cases where you need both. Absolutely, I think so.
Yeah, so this is a question we get quite a bit. Like, hey, what's RisingWave? How is it different from Pinot, right? There are different categories. Obviously, one is the stream processing database. The other is a real-time OLAP system. But there is an overlap, right? So we call it more co-optation because we have some of our customers use purely for stream processing, use RisingWave as a ETL engine, and then push the transform data to downstream system like Pinot or ClickHouse or whatever it is. But that's their user-facing engine because they have built-in optimizations for high concurrency and a lot of other things that they do. So I feel like it's complementary. Can one do everything the other does? Not all of it, but there may be some use cases where you may have to. I don't know if you're able to hear me. Yeah, but there are some use cases where you don't need both. But if you have stringent SLAs and you have repeatable pattern in terms of incremental building of those MVs, then you're better off using a streaming ETL engine to prepare those, at least the base data sets, which act as as your base table, so to speak, for your real-time OLAP engine.
So last words maybe from me. So this is mostly also about this distinction between row-based and column-based storage, right? Because if you have data in Kafka, this is, if you look at it from this angle, it's row-based, right? You basically, so if you use Debusmann, for example, like before, you have individual rows flowing into Kafka topics as one message. And on the other hand, for example, Pinot, like we had in the talk before, organizes the data in columnar mode. Also to have indexes and to have aggregations pre-computed and the star tree index and all that. And these two modes of operations of databases are kind of complementary. It's very hard to put them into one system. I mean, there is actually a nice approach. Not try. That's too bad. But there's some systems trying to really combine both row-based and column-based. One I know of is Time Plus. So they basically have a row-based stream processing engine plus another column-based, ClickHouse-based columnar engine. I don't know if it's good to conflate too many systems into one, but it's an interesting approach, definitely. And it's I don't really see kind of a system which has one engine for both, which doesn't, where the difference doesn't shine through. I mean, with Time Plus it shines through. With Confluent it does shine through. So you also have row-based, that's Kafka. You have Tableflow now, which is column-based. There will always be some kind of a difference as far as I see it. But yeah, let's see what happens.
Yeah, I agree to that. I mean, even if you look into the database world, and SQL is around for 50 years, how many database systems out there? 100, 150, 200? Everything is specializing on a certain aspect, right? So if you say, I need to combine some of those aspects, then maybe you need to build a specialized engine, but you will never build one system that has all the benefits and none of the drawbacks. It's just not impossible. It's just not possible, right? I mean, computer science is about trade-offs. And I guess then the most successful systems are just those that are basically generic enough to serve a broad variety of use cases. But you will always have niche systems where it's kind of, okay, I really need to specialize on this because that is very important for me to optimize. So I think we only will get more systems, not fewer. And obviously some will also die off because, you know, it's random ideas. But there's no one size fits all.
More audience questions?
Yeah. Okay. Since this Kafka 4.0 has released, so I just want to bring that on because I've been working around a decade on Kafka and Hadoop and all. Kafka has the scalability issues and repartitioning. So that was like main problems for me. So with Kafka 4.0, okay, I agree on the Zookeeper part. So that is there, but that is now removed. Now, are those scalability issues solved? Can I say now Kafka is auto scalable and it does the auto repartitioning? What is your opinion on Kafka?
Yeah, in open source, there's no such thing, no. In Confluent Cloud, we have it. So, sorry, but yeah. But that's also the point, right? I mean, as a company, we contribute a lot to Apache Kafka, but obviously we cannot contribute everything because then there's no business, right? So we need to keep a balance here. But yeah, I mean, I think a big advantage, and they said it's GA for a while already, to make Kafka more scalable is tiered storage, because then you need to move fewer things. The other point is also from a community point of view, there is limitations how much you can actually do, because I mean the community is very healthy. We have a lot of contributions, but in the end, it's too small to build all these things. And we had very often discussions about, let's add feature X, Y, Z, and then it's kind of, yeah, but who is actually building it and who is maintaining it? And then it just doesn't happen because there's nobody there. I had a discussion with this just recently with somebody. So at Confluent, I think we have about like 800 engineers, and of course we built like a huge, massive thing. And the Apache Kafka 4.0 release was the release with the most contributors ever, and it was 130. So you see the difference, right? And the point is also of those 130s, there might be a couple of people who have like 1 or 2 commits, so fixed like a typo in a Java doc or something like that. It's not 130 full-time engineers. So maybe you have like 30 full-time engineers doing that, right? And so it's just not possible to build these things. Obviously, the tying to partitions is a big problem. And having something like a partitionless Kafka would be an awesome thing. But it's also not something you build overnight. So maybe it comes with 5.0 in 5 years, who knows? We have to see, but yeah, it's for sure something that's still there. And then there's other open source tools for auto rebalancing from LinkedIn cruise control and stuff like that, that are very, very mature, that you can then just, add on and use in combination.
It looks like no more questions. We all break for an early lunch, but before that, 1 minute closing thoughts from each of you on what do you predict will be new and latest greatest things in the world of stream processing?
Okay, can you hear me now? Latest and greatest thing. Oh my God. From what we are hearing from the customer's perspective, I think it's more go beyond SQL, make it more easy for data scientists, for example, because that opens up to the utility of what you have in your database. Because when you start something, you want to be specific, focused on a particular workload. But the only way you can add to that is by adding more different types of functionality that expands the canvas. So I feel like, in my opinion, embedding support native, like what the stateful functions and Flink added, something similar, adding something to the databases would allow us to become more general purpose. Yeah, I think that's probably the best I can think of right now.
That sounds exciting because I think having support for like streaming data frames in a way which is already there with some libraries like Quix, this would be interesting in the future. Maybe even to have support for this in Flink or RisingWave. That would be definitely interesting because, yeah, it's always the same story, but when you have SQL systems or streaming SQL systems, at some point you want UDFs and then you want more and more. So SQL is also never enough. On the other hand, it's a standard, and yeah. But I think this is interesting. So I think in general the Kafka world, in my view, should go a bit more into Python than it is now because it's so general and generic, and you have so many tools which you have a hard time to build using Java or Kotlin or Scala. So yeah, these kinds of things.
You can always start an open source project with Python tools for Kafka. Everybody would love that. Yeah, no, I mean trends, I think, besides what was already said, so I'm not going to repeat that, I totally agree. Another very interesting trend that we are seeing for the last 2 years, it's still very new, is this idea of durable execution. Not sure if you ever heard of that. There's at least one company doing it, and so then basically, it's always hard to describe. I would say durable execution is a lower primitive, and then on top of that, you build workflow engines. And I think that can also be very powerful. So there's Temporal, for example. There's a company called Little Horse. They actually build on Kafka streams. That's why we know it. So I think that can also be a new trend that might pick up in the next couple of years. We watch the space. It's interesting. But yeah, it could be a new way to build applications.
Awesome. Well, thank you, everybody. Thank you, Rayees, Ralph, and Matthias. Thanks, everybody.